Okay, we're looking at the May-June 2024 paper, question 6. And here we are given the graph of f of x and g of x. And then D and E are the x-intercepts and P is the y-intercept of f. And then we are given the turning point, which is T. We are given the coordinate of the turning point, which is 1 and minus 4. And the graphs of f and g intersect at P and E. So 6.1 wants us to write down the range of f. Now remember that the range is all the y values. Where does my graph exist in terms of the y values? So this is my graph of f. And looking at this graph of f, the lowest point of f is this one here, which is 1 and minus 4. So the lowest y value of f of x is minus 4. So then you would say that the range would be y is greater than or equal to minus 4. Right. And then 6.2 wants us to determine the coordinates of D and E. Now D and E are the x-intercepts of f, right? So these are the x-intercepts. And remember that when we have x-intercepts, y is equal to 0. So in this case, we are going to take our function x squared minus 2x minus 3, and then we will equate that to 0. And then we can just solve for x. This is x 3, 1, minus, plus. So x is equal to minus 1 or x is equal to 3. Right. So the coordinates of D is the negative x value. So D is minus 1 and 0. And the coordinate of E is the positive x value. So then E is going to be 3 and 0. Right. So this is minus 1. This is 3. And then now we want the equation of G. Right. The equation of this straight line here. Now remember that the equation of a straight line is given by y is equal to mx plus c. So we need to determine the gradient, and to determine the gradient of a line we need 2 points, and we also need to determine the y-intercept. Now the y-intercept of G is this point here P, which is the same y-intercept of f of x. Now the y-intercept of f of x is this one here, which is minus 3, right? So we can immediately say that C is equal to minus 3. And now we need to determine the gradient of G, right? So we can use the point P, which is 0 and minus 3, and we can also use the point E, which is 3 and 0. So we can determine the gradient of PE, which is y2 minus y1, and then x2 minus x1. So we can say this is minus 3 minus 0 over 0 minus 3, and that gives me minus 3 over minus 3, which is equal to 1. So then we can say therefore the equation of g of x is equal to x minus 3. And then 6.4 wants you to write down the values of x for which f of x minus g of x is greater than 0. So we can rewrite this question. We can say this is f of x. We can transpose g of x, where it means now f of x is greater than g of x, right? Now what does this mean? F of x greater than g of x, meaning that f of x is above g of x, right? So let's determine where our graph of f of x is above g of x. So looking at this, f of x here is above g of x, and as well as this part here, f of x is above g of x. So our answer for 6.4 would be when x is greater than 3 or when x is less than 0. Right. And then looking at 6.5, we want to determine the maximum vertical distance between h and g if h of x is equal to minus f of x for the interval minus 2 to 3. So for this question, we are going to have a new graph, which is h of x, and then h of x is equal to minus f of x. So h of x is equal to minus f of x, right? So what is our f of x? F of x is x squared minus 2x minus 3. So x squared minus 2x minus 3, right? And then let's distribute the negative sign to get us negative x squared minus 2x, plus 2x plus 3. So now this is our function of h of x, right? Now let's go back to the question. We want to determine the maximum vertical distance between h and g. Now remember that g is our straight line, which we determined to be x minus 3, right? So we want to determine the distance between h and g, but not just any distance. We want to determine the maximum distance, right? Remember, whenever you want to determine the distance of something, you say y top minus y bottom, right? So now we need to determine which function is on top and which function is at the bottom, right? So g of x is still the same function, but then now remember that h of x is minus f of x, so which means that this graph here of f has just been reflected across the x-axis. So it's going to go down like this. Is just a rough sketch, right? It's going to go down as a sad face, meaning that the function that is on top is the green one, which is h of x, and the function that is at the bottom is g of x, right? So we want to determine the maximum distance. So we want to determine this distance here, right? So what we can say that the distance is y top. Now which function is at the top? That would be h of x. So minus x squared plus 2x plus 3 minus the function which is at the bottom, which is g of x, which is given by x minus 3, right? Then we can just clean this up a little bit. Plus 3 minus x plus 3, right? So this is minus x squared, and then 2x minus x gives us plus x, and then 3 plus 3 gives me 6. So our distance is given by this function here. Now remember that we want to find the maximum distance. So when you think about maximum and minimums, you can think about the first derivative. So at this point, we can take the derivative of this distance here. Let me call this capital letter D. The derivative of the distance with respect to x, right? And that gives me minus 2x plus 1. So I just took the first derivative of this part here. And remember, when you want to find maximum and minimums, we can equate the first derivative to 0. And then we can solve for x. So x is equal to 1 over 2, right? And then I can take this x here and plug it back in to my distance equation. So then I can get d is equal to minus 1 over 2 squared plus 1 over 2 plus 6. So that gives me minus 1 over 4 plus 1 over 2 plus 6. And if you solve for that, you should get you should get 25 over 4. So you can just say units. So that is your maximum distance between h and g of x in the interval, right? In the interval that we were given here. Okay. And then 6.6 wants, okay, they are saying that given k of x is equal to g of x minus n, determine n if k is a tangent to f. Now remember that a tangent is a line that only touches the graph once, right? So now this means that this part here, k of x equals to g of x minus n, the part of g of x minus n, remember that general equation of a straight line is a of ax plus q, right? Or you can say mx plus c. So this q or this c is what is going to shift our graph up or down by q or c units, right? So this minus n is going to shift our graph some n units for us to have a tangent, right? So this is g right here, and then if we shift g down by n units, it's only going to touch the graph of f. It's going to touch the graph of f of x once, right? Because we want determine n if k is a tangent to f. So now we want to determine how many units should we shift g of x down so that it is a tangent to f of x, right? So now to work out this question, I can use a concept called the nature of roots, right? I'm going to use the concept called the nature of roots. So that is 6.6. But before I get there, what I'm going to do, because we want, if k of x is a tangent, meaning that at that particular point the two graphs are equal, right? So they have the same x value and have the same y value at this point here where k of x is a tangent to f of x. So I'm going to say that f of x is equal to g of x minus n, right? Because the graphs should be equal at that point where they touch each other and form a tangent, right? So remember that f of x is x squared minus 2x minus 3, and then g of x is x minus 3, and then you also have this minus n right here. Let me just double check if it's x squared minus 2x minus 3, and then g of x is x minus 3, right? So now I've equated these two graphs. So now what I'm going to do, I'm going to bring everything to the left hand side. So I have x squared minus 3x, and then minus 3 plus 3 is 0, plus n is equal to 0. So this is what I have at this point. So remember, if I use the concept called the nature of roots, now this here is a quadratic equation, right, in the form of ax squared plus bx plus c is equal to 0. So the nature of roots, if my discriminant is equal to 0, I have one real root, right? Remember that a tangent is a line that only touches the graph once. So that would be similar to having one real root. If my discriminant was greater than 0, then I would have two real roots. If my discriminant was less than 0, I would have no roots. But at this point here, we are only focusing on our discriminant being equal to 0. Remember that the discriminant is equal to b squared minus 4ac AC. Looking at this equation here, my A is equal to 1, my B is equal to -3, and then my C is equal to N, right? So then I can say, okay, B squared minus 4AC is equal to 0, and then my B is -3, my A is 1, and my C is N, right? 3 squared is 9. This is 4 times 1 times N is 4N is equal to 0. And then I can just say minus 4N is equal to -9. So N is equal to 9/4. So I can shift this graph. So I can shift this graph of g of x 9/4 units. So 9/4 is about 2,25 units. So if I shift this graph here of g of x 2,25 units, it's going to form a tangent. It's going to become a tangent to f. Okay, for interest's sake, let us determine actually the coordinates of that particular tangent. And we can just go back to this point here. So we have x squared minus 3x plus 9/4 is equal to 0. And I can just solve for x here. I can use the quadratic formula, minus b plus minus the square root of b squared minus 4ac all over 2a. And I can just plug in my a, b, and c. This is minus 3 squared minus 4a c all over 2a. And then first x value is so the first x value is 3/2, or x can be equal to oh yeah 3/2. Yeah, this is correct. I am actually supposed to only get one x value, because remember the graph will only touch f of x once, and it will only touch f of x at this coordinate at the x value of 3/2. So that would be somewhere, yeah, because this one here is 1, and then 3/2 should be, yeah, should be somewhere here actually. So this is the end of this video. Please like, share, and don't forget to subscribe.